In the previous video, we took a look at being able to construct a scatter plot for bivariate data. We took a look at how to get the least squares regression line, and then also how to get the linear correlation coefficient, as well as the nonlinear correlation coefficient, which ended up being the same thing, approximately. Now, what if we want to assess the normality of the data and then also assess the errors that are going on with this sort of thing? So in other words, we're looking for the residuals. So let's move this graph. And what I'm going to do is I'm going to use the equation. Right? So right here we have our equation 0.0009x. And remember, a residual is just going to figure out what the actual minus the predicted. So let's figure out the y predicted first. To figure that out, what I'm going to do is I'm going to substitute x back in to this data right here. So I'm just going to say equals 0.0009 times, now notice that this is cell C3, right? So it's column C, row 3. So I'm going to say times C3, and notice I have an equals there. Remember, an equals defines it that you're starting a formula. And we're going to say plus 0.369, right? And that gives me the y predicted for the first. All right, now I'm going to get rid of that dollar sign in a moment. I'm just going to change this to a number. What I'm also going to do is taking this box right here, this box in the lower right-hand corner, I'm just going to drag it. Right? And what that does is it finds the predicted value for all of the different payrolls. All right? So this is the predicted win percentage. Now what I'm going to do is I'm going to highlight the data to get rid of this dollar sign. I'm going to right-click. And what I'm going to do is I'm going to format the cells. For some reason, it's on currency. Let's just say general. And that's good. All right. For some reason, Excel wants to go out to 5 decimal places, which is perfectly fine. All right. Excel doesn't hurt our feelings by doing that. And now what we can do is we can figure out what the residual is. All right. So here's what I'm going to do. First, I'm going to name it. So here's the residual name, and this is pretty cool. I'm going to say E1, E2, and then what I'm going to do is I'm just going to drag. And notice in the bottom right-hand corner, Excel's smart enough to know that I'm just naming those. All right, so if you start a pattern, Excel will usually go in that pattern. All right, so pretty cool. Like for instance, maybe I did, and you don't have to do this, but maybe I did E2, E4, E6, and I had that pattern. Notice what happens. Excel goes in 2s instead. All right, so Excel is actually pretty smart about determining at least arithmetic patterns. All right, so I'm just going to say E1, E2, and then I'm just going to drag this, and that's our names. And then here's the actual residual. And to figure that out, what I'm going to do is I'm going to take the y actual, which is the winning percentage right here. So we can actually call this y actual. And I'm going to subtract from that the y predicted. So that's going to be equal to this cell, which is the actual, that's D3, minus the predicted value, which is E3. All right, so here's our residual. And then what I'm going to do is I'm just going to drag this. So I'm going to grab the box and just drag it down. And what that does is that gives me the residuals for all of the data. All right. All right, so now we can construct a residual plot. Right? So underneath right here, what I'm going to do is I'm going to construct a residual plot. So to construct the residual plot, I'm going to do the exact same thing I did as a scatter plot. I'm going to highlight this data, both sets. So we have our name, and we have our residual. We're going to go to insert. We're going to insert a scatter plot, and it's a residual plot now. Right? We want to make sure that we label things correctly. So we're going to go plus, we're going to have some axis titles. All right? So this is just our residual name, which unfortunately does not show up. All right, so if you really wanted to, you could just click in this box here and just delete that. And right here, this is the residual value. All right. And if we wanted to be specific, what are we looking at? We're looking at the residuals of team payroll versus win percentage. All right, now, we look at this and we notice, okay, well, this point right here, which is the very last one, E30, is probably going to be a residual. It might be a suspect point. All right, so if I look at that, one thing that I notice is that E30, which is really the point 64.2, comma 0.593. All right, that's suspect data right here. All right, just because that one's really high compared to all the other ones. Notice how high this one is. It's the highest residual. So what we would say is that E30, which corresponds to the point, is suspect. Right? Now we're going to see in a moment that it's not necessarily going to be an outlier. And then down here, this looks like it's E20 as well. All right, E20 is a really low value. All right, so notice we have a negative. It might actually be the furthest from the line. So we go up to E20, we have this one, and E20 corresponds to the 4 Detroit Tigers, who have Miguel Pereira on their payroll and several other very high-priced people, but they just did not win a lot. In fact, they lost the most games in Major League Baseball last year, despite having a relatively healthy payroll. So we're going to say E20, which is equal to the point 114.1, comma 0.292, or 0.292, doesn't matter, is also suspect. Right. But the question is, are they really outliers? Right? Are they suspicious or not? Are they just suspicious or are they not outliers? So here's what we can do. We can construct a box plot, and the box plot in Excel will determine whether or not there's any outliers. Right? So what I'm going to do is I'm going to highlight all this data for the residuals, and this is a residual of the box plot. I'm going to insert, and I'm going to go over to the histogram. I'm going to drop down, and then here's your box plot right here. Now we are going to put some labels in here. So I'm just scrolling this down a little bit. Nice professional looking graphs. So we can go through and we can add our titles as usual. Now this one doesn't matter, so I'm going to delete this. And all I'm doing is I'm just clicking on the box and I'm hitting the delete key. I don't know what happened there, but I'm going to get rid of this one. And these are just our residuals, right? Or just residual. And this is just, again, a residual of the box plot of the residuals. Now, notice how nice and even this box plot is. All right, so the whiskers from the box plot are almost equidistant from the high and the low. And right here in the middle, this number is pretty close to 0, right? So this is our median value right here. All right, so it really doesn't look like there's much any outliers. And let me do this just to show you what an outlier would look like. Let's change this very last point. All right, let's say for some reason I was to make it 0.999 or 9999. Clearly that's an outlier. All right, now see how it changes all the graphs. All right, so notice that this point now is all the way very, very far, and these look like they're pretty close together. And notice that there's this outlier point right here. Even if I changed it to 0.77, it's still an outlying sort of value. We have that dot there. Even 0.4 is going to be an outlier value, right? I think 0.3 is still an outlying value. All right, so this is how we can see outliers using Excel, is that there's this point that's just so far away from the remainder of the data. Now 0.25, all right, that's when, okay, it says, okay, well, that's not an outlier anymore according to the box plot. All right, so now I'm just going to go back and get the original graph, okay, because that's what we really care about. All right, so what I'm going to do in the last video for this, at least for this problem set, is I'm just going to do an analysis of this. In other words, try to answer some of the questions that you'll be asked to answer as well, based on this data.